We have already seen the use of the plus sign to perform addition. A plus sign can also be placed to the left of a variable to coerce it to a number. This is known as a unary plus. If I remove the unary plus, the output is the string 52 because the number 2 is coerced to a string and concatenated with the value of x. Because the unary plus converts the value of x to a number, it is possible to add it to the number 2, which results in a value of 7. Note that there are other ways to convert a string to a number. We will cover these techniques at a later time. The minus sign can be used for subtraction in the same way as in math. There is also a unary variant of the minus, which is known as unary negation. Negative numbers are preceded by a minus sign. When the minus sign precedes a variable name, it doesn't indicate that the variable has a negative value. It instead becomes a mathematical expression with a value equal to the additive inverse of the variable's value. This causes a positive value to become negative, and it causes a negative value to become positive. The value of y is positive 7, so unary negation of y is negative 7. The value of z is negative 2, so unary negation of z is positive 2. We don't use the letter x for multiplication. That could cause problems because x can be used as a variable name. The real multiplication symbol actually isn't an x anyway. This is why HTML has a special code for that character. On the left is the lowercase x, and on the right is the multiplication symbol. These are both in the same typeface and size, but they are slightly different in appearance and screen readers will read them differently. The actual multiplication symbol is not easy to type on the keyboard, so this character is also not used for multiplication in JavaScript math. We instead use an asterisk for multiplication. Note that multiplication must always be done explicitly. In algebra, it is possible to have an expression like 3y, which multiplies y by 3, but this is not permitted in JavaScript. The asterisk for multiplication is always required. A double asterisk is used for exponentiation. For division, we also need to use a substitute character because the division symbol is not easy to type. We use a / for division. JavaScript also has a modulus operator for computing the remainder of a division. The percent symbol is used for the modulus operator. Note that there is no operator for percents. If you need to work with percents in JavaScript, you will need to handle the multiplication and division by 100 to perform the conversions. We have already used the equal sign for assignment numerous times. One aspect of assignment that we haven't covered yet is that an assignment is both a statement and an expression. It's a statement because it causes something to happen. A variable's value is set. It's an expression because it is code that can be evaluated to produce a value. For example, 5 plus 7 produces the value of 12. Assignments produce the value that is being assigned. X is assigned the value of 7, but the assignment itself also has a value of 7. One consequence of this is that it is possible to chain assignments. What happens here is y is assigned the value of 5, and the assignment expression also produces a value of 5, which is assigned to x. So both x and y end up having values of 5. It is rare to chain assignments like this, but it is common to accidentally use the value of an assignment expression. This commonly happens in an if statement when the intention is to check for equality, but only a single equal sign is used instead of a double or triple equal. The condition is treated as truthy despite the fact that 5 is not equal to 7, because the expression is an assignment and not an equality comparison. Since the expression x equals 7 returns the value of 7, this code is equivalent to having 7 as the condition. Recall that all numbers are truthy except for variants of the number 0 and NaN, which means that 7 is a truthy value. This common mistake can go unnoticed because it isn't illegal code, so no error message is generated and the program runs. It just doesn't produce the correct output. Replacing the single equal with a double or triple equal results in the correct output. When assigning the result of a computation to a variable, it is important to remember that the assignment is fundamentally different from a mathematical equation. A mathematical equation asserts that two values are equal, and you can then derive information based on this fact. An assignment is an instruction to take the value on the right side of the equal sign and give that value to the variable on the left side. Because of how assignment works, we can do something like this to increment a value. In regular math, this would not make sense for any value of x other than infinity, since no regular number is equal to one more than itself. Because this is an assignment, it is completely valid JavaScript code. What happens here is the value on the right side of the equal sign is computed first. X has an initial value of 5, and 5 plus 1 is 6. The value of 6 is then assigned to X. It is possible to use the same variable name on both sides of the equal sign for all mathematical operations. Because it is very common to perform math on a variable's value and to reassign the result back to the same variable, there is a shorthand for this. Let's first see how this is done with addition. The x on the right side of the equal sign is removed and the plus sign is moved to a position immediately left of the equal sign. This statement adds 1 to x and is equivalent to writing x equals x plus 1. Note that the plus equal is considered to be a single operator. The same shorthand is available for all of the mathematical operators that operate on two values and return a result. They work the same way as with the plus equal. Remove the variable name on the right side of the equal sign and move the mathematical operator to a position immediately to the left of the equal sign. There are additional shorthand forms for incrementing and decrementing by 1. 2 consecutive plus signs increments a value by 1, and 2 consecutive minus signs decrements a value by 1. Note that the increment and decrement operators can be positioned either before or after the variable name, but the meaning is different. You won't see any difference in this specific example, but there is a difference when the value is being used within the same statement in which the increment or decrement happens. This code outputs different values for x and y because placing the increment operator after the variable name causes the increment to happen after the assignment. So y gets the value of 5 before x is incremented to 6. This specific variant of the increment operator is known as a postfix increment. Placing the increment operator before the variable name causes the increment to happen before the assignment. The initial value of x is 5, and that is incremented to 6 before y is assigned its value. So y gets the value of 6. This specific variant of the increment operator is known as a prefix increment. There are also prefix and postfix variants for the decrement operator. In this code, the assignment happens before the decrement, so y gets the value of 5 before it is decremented to 4. For the prefix decrement, the value of 5 is decremented to 4 before the value is assigned to y, so y also gets the value of 4. The increment and decrement operators can only be used on variables. For example, it cannot be used directly on a number. This is illegal because it is equivalent to assigning the value of 6 to 5. As I mentioned in an earlier video, numbers cannot appear on the left side of an assignment. The 5 must always remain equal to 5 and cannot be assigned any other value. One consequence of this is that it is not possible to chain increment or decrement operators. The first increment produces 6, so the second one would need to increment the number 6, which is illegal. This also means you can't mix prefix and postfix increment or decrement operators on the same instance of a variable. All 4 of these combinations are illegal. It is also not possible to use the increment or decrement operators on a constant variable because constants can't change, so they can't be incremented or decremented. You may have heard of something in math known as order of operations. We have something similar in JavaScript which is formally referred to as operator precedence. The difference is that precedence determines how values are grouped with operators instead of determining when a computation is performed. This makes an important difference with postfix increment and postfix decrement, which we will see in a moment. The mnemonic acronym PEMDAS encodes parentheses, exponentiation, multiplication, division, addition, and subtraction. JavaScript follows this, but has a lot more operators, including ones that are not used for math. If we focus only on the mathematical operators, the order of operator precedence is shown in this table. Parentheses have more than one use in JavaScript, but when used in mathematical expressions, they serve the same purpose as in regular math to increase the precedence of whatever is inside the parentheses. In the first version of this code, there are no parentheses in the mathematical expression. Note that the outer parentheses are for the console log and are not being used mathematically. Because this expression doesn't have parentheses and multiplication has a higher precedence than addition, the 2 times 8 is calculated first. The resulting value of 16 is then added to 5, which results in the output of 21. In the second version, parentheses give the 5 plus 2 higher precedence, so that is calculated first, resulting in a value of 7. This 7 is then multiplied by 8 to result in 56. Postfix operators perform their increment or decrement after the whole expression has been evaluated, so you might expect them to have the lowest precedence, but they actually have very high precedence, which is surpassed only by parentheses. Precedence determines the order of evaluation. If we use a triple plus between two variables, this is interpreted as a postfix increment of x followed by addition because the postfix operator has higher precedence than addition. If addition had higher precedence, which it doesn't, then this would have been interpreted as addition followed by a prefix increment of y. Note that the high precedence of postfix operators also makes it illegal to have two minus signs in between variable names without any spaces. What happens is the code is interpreted as a postfix decrement on x, and the y variable name follows immediately after without any operator to specify what operation is to be performed between x and y. If your intention is to apply a unary negation operator on y and subtract the result of that from x, this can be fixed by simply adding a space in between the two minus signs, but you may also want to use parentheses to make the code easier to read. Note that the same problem exists with having a double plus sign in between variables. This is interpreted as a postfix increment of x followed by y without any operator to specify what operation is to be performed between x and y. If the goal is to perform a unary plus on y and add the result to x, this can also be fixed with either an extra space or parentheses. Associativity determines how operators are grouped with values when adjacent operators have the same precedence. Exponentiation is right associative, which means 3 raised to the power of 2 is evaluated first to get 9, 4 is then raised to the power of 9 to get 262,144. For comparison, division is left associative. 24 divided by 4 is evaluated first, which results in 6. The 6 is then divided by 2 to get the result of 3. Exponentiation and assignment are the only mathematical operators that have right associativity. All other mathematical operators are left associative. The right associativity of the assignment operator is what allows the chaining of assignments. If it was left associative, x equals y would be computed first, and both variables are undefined at this point. The 5 would then be assigned to undefined, which is not allowed. There is more to math beyond operators. There is also more to using numbers than doing math. We will cover these topics in the next video.